Hello, everyone, and thanks for staying that long for my session. We're going to talk about RX.NET way of async programming, and in this session, we're going to cover the core idea that construct the RX API, and hopefully, with that core knowledge, you'll get a better understanding how RX is working from inside, and perhaps with that knowledge, you make more extensive use of it in your applications. So let's get started. How many of you guys have seen this before? And personally, I'm as a developer, get a little bit frustrated whenever I see those kind of problems, because you kind of have an idea what might have caused it. So that's not what we want. We don't want to write application like that. So what do we want? We want to create application which makes our users happy. That's simple as that. But what is happiness? Well, happiness means responsive applications. And responsive application means asynchronicity, which will typically add complexity to your applications. And that will end you with a headache for us as developers, right? So I would like to introduce reactive extensions, or add their short name RX. Basically, your headache pill for synchronous event-based applications. So why RX? I'm not going to talk about the bad things tasks give us. Rather that I love async await, and I think they made our async life much easier. But the thing I don't like about them is it doesn't let me to be concise. And the reason it doesn't let me to be concise is it doesn't help me to get rid of state, immutable state. Basically, the enemy of any user interface application. And the other thing is, I want the idea, the feature description, I want it all to be in a single, readable piece of code. And the thing I'm mostly excited about RX is it lets you write more dependable, more reliable async code. You basically write it down once and you know it's going to work every single time. And they're testable. You can have the same piece of code run concurrently in your production, and it can be ran synchronously in your unit tests. And the RX helps us by abstracts away the concurrency from us. So let's go through quickly about our agenda for today. We're going to talk briefly about pull versus push model. Then we're going to start by building our own RX API. We're going to learn about callbacks, first building blocks, and then we're going to add a few RX operators. And eventually, we're going to get to live demos. So let me introduce myself. My name is Stas Rivkin. That's my Twitter handle. And yes, I do speak Russian. But frankly, I'm not fluent with software terminology in the Russian language. So that's the reason for this talk in English. Feel free to ask me questions at the end of the session in Russian, and I would try to answer them. I'm a software consultant from Israel, and I work at CodeValue, which is a software consulting company. It's also the proud development center of Oscode, magical debugging extension for Visual Studio, for those of you not familiar with it, and it's a shame. It has few key features like visualizing link debugging, and it allows you to filter collections by property names or even their values while debugging. I have more than 5 years of .NET experience in .NET C#, And I'm also an OSCode evangelist. I wrote a few blog posts about how to MongoDB in C#, and you can find them at the OSCode blog. So that's about that with the self-promotion. It never hurts, right? So let's try to understand what we're seeing here. Here we have sum and average, and they are observing the changes that perhaps happened in one of the end cells at the cells column. And whenever one of the cells changes, it will push that notification of the change into the sum and average, and they will update their own values. But try to think about the other way around. What if they won't push their values and they'll do some sort of polling? It means sum and average will have to query what each of the end cells at the cells column, basically in some sort of endless loop. Are we changed? No. Are we changed? No. And hopefully we'll get that single time whenever one of the values might change. And that's basically a waste of time and resources. So let's differentiate between the two models. Here we have a simple pull model. We get the hashtag, and we want to query the social media for the statuses, tweets, and updates. But this kind of code will end you up with the same blocking application as we saw before. So let's async it a bit. That's it. There's no more blocking, and the users are probably happy, or are they? Because think of a different scenario. What if Facebook and LinkedIn would take merely 1 second to retrieve the results, but Twitter might take you up to 5 seconds before it bring you some results? The user will have to wait a whole 7 seconds before he or she can interact with your program. And that's not quite responsive, right? So what if we had some sort of a framework that we could specify a target method and do the same kind of query, but whenever the results will come in, they'll be pushed into our target method. And here Facebook brings us the results after 1 second, same as LinkedIn. And Twitter will eventually catch up after 5 seconds. But the key difference here, our user can interact with our program after merely 1 second. And that's awesome. So let's try to understand what that magical type marked with question marks. And I think the best way of understanding something and learning it is by building one. So why don't we build our own Rx API and see how it works from the inside. But before we're going to jump into code, as a good API designer, first we have to see all the use cases we might need to handle. Here we have a simple list, and the idea here, we want for each item to push it into our callback, which eventually will print it into the log, the console. Let's see a different scenario. Here we have a button, and the button has a click event. And the idea here will be whenever the user clicks the button, it will push that event to our click handler. But what about async? Well, here we have a simple web client, and we're gonna await the result from some made-up URL. And whenever we're gonna await that value, it will be pushed into our next callback. But as you might know, awaiting a task or even HTTP might throw exception one at a time. So we need to defend ourselves against it, and perhaps we want to handle that error in some sort of way. So we're going to have to add an error handler. And whenever the error happens, we're going to push that into our error handler. But what about the scenario when we have numerous values? Well, we want to get notified when that's it. The normal values to process. So we're going to add a complete handler. And whenever we finish iterating over the values and await them, we're going to notify that that's it. So let's summarize it. What do we want? Well, we want a single language to rule them all. Because events, callbacks, and waiting for a task to be completed are all basically some sort of events, right? Because you're doing some sort of a job and you want to get notified when they're done. But I can refer to them in a single language because I need a func of something for the callback, and I need a delegate of some sort for the event, and I will need to await the value of a task. So I'm treating all of those unified things as separate. And if I'm treating them separately, it means I can combine them. And if I can combine them, it means I can describe how they relate easily. So why don't we build the most generic API as possible, which has a single unified language, which will encapsulate all of those use cases we saw before. So let us start. Here we have a need data. And we know whenever we need data, we're going to pass a next handler to push the data to it. But what about errors? Well, we know we need an error handler, right? And what about completion? We want to get notified when there's no more values to process, so we're going to add a complete handler. And since it's a generic API, I choose to work with arrays. And I think you all can predict the output. But I want to take your attention to the need data method. Why did I call it need data? Well, in a typical synchronous scenario, typical synchronous scenario, I'm going to ask a method for its data. It's going to calculate something and return that data for me. Okay, but what about asynchronous scenario? And try to think about what we had prior to async await. We had to pass a callback to the continuation method of a task in order to get those values from it. So that's the reason for the need data. Perhaps it's not the best name, but it's still just a name. And here we have our initial draft of our new API, but I think we can do better. And why don't we do a small trick and refactor the code a bit and bundle all of those three methods into a class. And since we're printing to the console, I'm going to call it console observer. Okay. So by doing so, we introduce, unfortunately, a problem. Because now our need data is coupled to the console observer. And by looking at the console observer API, it basically reads as an interface. So why don't we extract all those three methods into an interface, and by doing so, remove the coupling from the need data. Let's update the need data method. Awesome, normal coupling. I want to do another small trick. I want to rename the need data method into something different. I want to call it subscribe. And it's still just a name. It doesn't change what the method does, right? But I still don't like our new API. And so going to propose we extract this method also to a separate class. And as we're extracting it, why don't we extract that void subscribe iObserver method interface also to a separate interface. Okay. Let's stop and analyze what we saw here. We have an observer, and it observes something, so that something is an observable. Ta-da! But there's a problem here, and the problem with our subscribe method. Think about a different implementation. What if we had the button inside our subscribe method? Well, for each subscribe call, we're gonna register an event handler to its event inside the subscribe method, and basically allocating a resource without even the user knowing it. And that might cause a problem because we didn't give the way of releasing that resource. So I want to propose something. Why don't we change that void return type into a dedicated interface which we already have inside of the C# and the .NET, and it's called iDisposable. And the idea will be that we're going to return an object that encapsulates the release management logic inside its dispose method. So let's change that void return type into iDisposable one. And I cheated here a bit. I used disposable.empty from the Rx library, and it's basically an object which does nothing whenever its dispose method is called, because basically we don't have anything to dispose of, right? We're iterating over an array. But it will be a different case if we had the button here, because we could add the unregister handler inside of that custom dispose object. The other thing I want to do is I want to take that hard-coded values and extract them, because it's never a good thing to iterate over hard-coded values. And I want to pass them as a constructor parameter into our observable. Awesome. And a good thing happened here, because we basically removed any sort of coupling to a specific integer operations. We now have pretty generic observable without any coupling to a specific type. And so if we don't have any coupling, why don't we transform it from observable to observable of t? Awesome. By looking at that observable, we pretty much understand the purpose of that class. And its purpose is to take an enumerable and to transform it into observable. So why don't we rename that class into its purpose, which is to observable? And since we're in C# and we love extension methods, why don't we take the whole creation of that class and wrap it into an extension method? Great. But I want more. Arrays and enumerables have awesome features thanks to LINQ, such as filtering values using where and projecting new values using select. And I wonder if we can add the same abilities to our API. And to answer that, yes, we can. So let's start with where. And the idea will be to continue with the same principle and create a class called where and wrap it with an extension method called the same way. But there's a key difference here. And the difference here is we're going to pass a filtering function, and the previous observable and not enumerable. So here we are storing our source observable and the filtering function. And I want to ask you, how can we get the values from the previous observable without breaking any encapsulation? Because iObservable only exposes a subscribe method. But we already know that subscribe method exposes a parameter which it accepts into it as a parameter, is a method parameter. And it accepts an iObserver. So I want to propose something. Why don't we, as a where, implement the iObserver, and by doing so we could push ourselves as a method parameter into that subscribe method of the previous observable, which is our toObservable, and by doing so we're going to iterate over its values. And this is where the magic happens. So let's squeeze that subscribe method and implement our iObserver. So by passing ourselves as a parameter, we're now going to get all of the values to our own next method. And now we can filter the values. And for those values which passes our condition, we're going to delegate them into our own observer, which we got here, which is our console observer. And by doing so, we're going to print them to the console. But I want more. I want to be able to project values from one type to another. I'm going to use it using a select. And to continue the same principle, I'm going to create a new class called select and wrap it with an extension method called the same way. And the difference here, we're going to use a selector function, which will project one value to another one. So the difference here is, instead of filtering the values, we're going to accept them as they come along, and we're going to project them into a new value and push them into our observer, which is this select class is also our previous console observer. And now let's use some sort of animation to understand how the data is flowing inside our query. So here we are filtering the first value because it's not greater than 10. The second one we pass, the third one we pass, and in the end we want to notify that's it, we're done. So you probably ask yourself right now, why do I need it? Because I mean, we're doing basically the same as link, but we're adding another layer of abstraction to do the same. And to answer that, I basically choose link similar operations to ease the transition from enumerables to observables. And to be honest, Rx has a lot of operators, many, hundreds of them. And I try to categorize them into the most commonly used ones. And as you can see, we have time-based operation, timeout, time interval, and we have defer execution operation, and we have scanning, and many, many, many more. And you can get all of this magic by downloading the NuGet package called system.reactive. But that's kind of okay for a cute example, but we want to see more real-life examples. So let's jump to our live demos. So we have our project manager, and he asks us to implement a cool feature, which is Google search. And we got a few requirements. The first one, at least 3 characters long. And the other one, do not send the same string again. And before we're going to before we're going to see how Rx solves that problem, let's see a simple implementation. Here we have a simple WPF application. We have a text box and a list box to populate our results. And we can see it works. So let's see the code causing that magic. Here we have our text box, and we are assigning an event handler to its event. And whenever the text is changing, we're going to verify our conditions, and if those conditions are met, we're going to save our token and send it into our search service. And that's simply a stub. I'm basically generating dummy results and waiting for 1 second to mimic a web request. And as you can see, it works. But we're about to ship it, and we got a bug. And the bug is we're basically overflowed in our server. And the reason for that is we are basically sending a web request for every text changed. So we got a new requirement. And the requirement says, wait a second before sending, after each text change, before sending it. So in order to do it, we need some sort of a timer. And we're gonna initialize it to a half second. And whenever that half second passes, we're gonna jump to our event handler, which will send the result. But before we're going to jump to that event handler, if all the conditions are met, then we're going to restart our timer. And the idea here is to restart the timer because just before we waited a half a second, a new text change may occur, and we need to restart the timer again to wait a whole half a second. And as you can see, it works. We got a new requirement now. We want to solve the problem if we're sending a web request and it got delayed, and in that time we already changed our search token. And the idea would be we want to drop the previous results and ask for new ones. And to accomplish that, we're going to use a cancellation token. So here we are initiating our cancellation token, and we had a new flag showing us if the request was sent. If it does, we're going to cancel it and use that's a token associated with that cancellation token source. And I assure you, it works. But look at how much code had to be written in order to accomplish that simple feature. We have here, 22, 86, approximately 60 lines of code. And check out how much state we had to use in order to implement that feature. So I'm going to delete all of this. And I want to use Rx to do the same thing as we see here. And to accomplish that, first we're going to have to transform the event into an observable stream. Okay. Now for each event emission, we're gonna use select to project the event to the latest text, and I'm using underscore here because I don't care about the event. Now we want to filter those values. Great. If it passes, I'm gonna restart my timer. For half a second. Whenever it passes, I wanna make sure I'm not sending the same string again. So I'm gonna use distinct until changed. And now, whenever those conditions are met, I'm gonna request my results. And we said we only want the most recent results, so I'm gonna switch to them. And now I'm gonna move back to the UI, and I'm gonna subscribe to get the results. And voila, we have 9 lines of code to do exactly the same thing as those 60 ones. Okay, see we jumped to the number 3 because we dropped the previous one, number 2. So let's see the same diagram to see how the data is flowing. So here we have the first 2 dropped because they're not 2 characters long. Afterwards, we only have 4 of them. Now we're going to use throttling. So number 3 is dropped because we didn't wait it for a half a second before number 4 arrived. And by throttling it, we basically got a duplicate here. And so we had a distinct until changed. And we dropped number 3. Now both of them we're going to send to our server. But we said we want to drop the first one and only subscribe to the most recent one. So we're going to switch to it. And that's it. Let's see another example. Let's see a drag and drop. And this is basically my own definition of a drag and drop. And I highlighted the keywords. So on each mouse down on your target, start processing mouse moves until a single mouse up. So the same as before, we're going to transform those events into observables, and now we're going to compose our drag observable. That's it. And the beautiful thing about it, it reads almost as English, because I want to skip my mouse moves until mouse down. I'm going to take them until mouse up. But there's a small problem here. Take until will cause that observable to complete. And we already know that when completing, that observable won't produce any more values. So basically, we would like to regenerate that same stream, but if there were only an easy way to regenerate it. Well, fortunately, there is. Just add a repeat and that's it. Now we can drag and drop how many times as we want. And let's jump to another demo. Here we have a string, and each character here is represented by a model. And that model contains that character at top and left to help me to drag it. Pretty awesome, right? Let's see how the code needed to implement that simple feature. Sorry about that. We're getting an observer from the event, and we're composing it to a drag. Great. Now we can compose our business logic. And the idea would be for each event, I'm going to transform it into a point and pass that point to my applied flying drag. And this is the part where your brain is supposed to melt down, but don't worry, I will try to explain everything. And I'm using indent to explain my meaning. So it reads like move points, select many, observe on dispatcher, subscribe to results. And for each point, I'm going to use an item stream, which is basically my item collection transformed to observable. And we already know that when we transform an enumerable to observable, it will produce all the values as quick as possible. And for each item, here we have the item and its index. The item is our character. And we're going to wrap it using an anonymous object, which contains the item and a new point based on its index. Then that specific item will be delayed by 75 seconds based on its index. And after it's got delayed, we're basically going to update its coordinate, and that's it. That's all needed to implement that cool feature. So let's use another diagram to see what happened here. Here we have our event. It transformed to a point, and then that point uses the item stream to produce all the values. So this is where the magic happens, and let's drill down. But remember, we're using the point as our auto closure. Here we have the text spread as in values, and each value, each character has its index. And as we saw already, we're transforming each value using an anonymous object and moving it by its index. So as an output, we got the character and its new position. Now we're going to delay them. Well, each item will be delayed by 75 milliseconds based on its index. So the first one won't get delayed. The second one will be delayed by 75 milliseconds. The next one by 150, and etc. until the last one. And whenever there will be, after the delay, they're gonna spit out from that select many into our subscribe method. And this is a snapshot of a single mouse event, which afterwards produce that awesome trick. So let's summarize what we had seen here. It's a simple idea based on an observable pattern, and it's definitely not some sort of a magic. It's a rather simple implementation based on a decorator pattern. It's easy to compose between events, callbacks, and tasks, but unfortunately, there are so many topics I want to talk about, but there's no more time. So, and the topics are simple conversion between observables to tasks. You can get a task, do a to observable on it, add some sort of retry logic, and then transform it back to a task using toTask, and then await it. There's different types of subjects, which are basically the core units, which allows us to do all of the RX. You have this iScheduler, which is the core unit which abstracts away the concurrency, and you can unit test them using a derived class from reactive tests. So where do we go from here? There's tons of resources, and you can find them on the web page, and you can learn on it that Rx is supported in more than 10 languages. Basically, if you know Rx once, you know it in every language. I'm currently consulting in a web project, and the framework we're using, which is Angular, uses heavily Rx inside of it, and the only fallback between me and Rx JavaScript is basically JavaScript. This is their GitHub, and it's open source. You can download it and play around with it. But if you want more deeper understanding of it, I eager you to get this book, Reactive Extensions in .NET, by Tamir Drescher, which is a senior architect at CodeValue. It has a huge number of examples and a more deeper dive into operators and how to combine between them. And all of the examples will be published at this URL. And that's it. Thank you.
All right, so it's time for questions. And
thank you. So when you were showing the implementation for IEnumerable, is it really close to what is done in observable?
No.
Because, I mean, if you subscribe twice and the enumerable is not instantiated, there are going to be a lot of problems.
Right. Well, the actual implementation is using some sort of recursion in order for you to actually dispose that operation of subscribing to that enumerable, because if you have a really long enumerable, for example, getting data from SQL, you don't want to iterate over all of them, as I showed here, and it's a pretty naive implementation. The actual one will allow you to dispose of it.
Thank you.
no questions in that part? Okay, so let's go over here.
I'm quite new with React extension. I just have maybe naive question. Once you compose your processing pipeline, so how are you actually debugging it?
Sorry, can you repeat that?
Well, I would say that you have declarative-like syntax, and
Okay.
if something goes wrong, so how are you actually going to debug this?
Well, reactive extensions and linked are something that's called the pure functions. They simply work and they do not mutate your, causing a side effect. They're not mutating your data. You basically get input and produce an output, whatever an output it is. So if there's a problem with inside your pipeline, you basically need to add a breakpoint inside that operator, or if it's in a method group, add a breakpoint at your method, because I can assure you, same as link, Rx works. I hope that answers that.
Everything works unless there are bugs, which there are everywhere, of course.
Thank you. You mentioned that IEnumerable can come from SQL, for example. So do you think that Rx can be used on pure backend? So there are no user interface, no events like clicks and so on, only incoming web requests, for example?
Can you repeat again?
Is it feasible to use reactive extension on the server-side programming when there are only some requests from, I don't know, some UI and databases? So that's all.
Well, I'm gonna answer it depends, because depends which sort of architecture you use on your server. Because if you use, for example, microservices, there'll be less scenarios when you need to use Rx there, because well, basically the most common implementation of a microservice is stateless. So if there's no state, it's kind of hard for you to use Rx, and there's probably no good reason for it to be used. But it really depends. I did have scenarios when I did use Rx at the server side. Basically, when I had to aggregate results from different tasks, so I transformed each of the tasks into observables, and then I use an operator called merge to merge them all. And afterwards, I'll transform that observable to task and await it. And so I didn't need to use subscription and disposing it and all those stuff. And it basically handled for me.
Okay, thank you very much.
Next one. Good morning. I excuse myself, maybe I missed something, but as far as I understand, to use an extension, it basically leads us to overuse delegates to make it nicer. And is it a hard question of, for example, like having overhead of using delegate and to make your code beautiful?
So if I get the question right, isn't it some sort of abuse of delegates?
Yeah, basically when we use a lot of delegate, also in a wrong way, like callbacks and everything like that. So we basically have an overhead of a memory.
So I see you were at the Dina's lecture.
Yes, yes. And it's like on the one hand, the code is beautiful. On the other hand, you will come back to this code like 2 years later and rewrite everything to the pure code without any delegate and extensions.
Okay. As mentioned at the beginning, the idea of Rx is basically to provide a single language which allows you to easily compose between task events and callbacks. Because we saw the UI code when we had to use 2 delegates for the events and also use an event, also await the result. So by using it, basically you abstract away and you write it down all in a fluent interface. So perhaps it has some sort of an overhead, depends on the scenario, because if you are not using some sort of computation, and there's no really reason for you to be concerned of memory allocations and so that sort of stuff, because you choose to work in OOP language and high-level language such as C#. And if you're afraid of memory, so it depends on the scenario. You're probably going to want to use C++ for if you have a memory issues, such as Dina specified. But in the most case scenarios, that will do. I mean, you don't need to be afraid of memory allocation and stuff like that. So that's my answer.
And if something goes wrong, you can always have Adam and Dina working on your code to rewrite it to something that works even better than C++. Do we have any other questions? We have a little bit of time. No. Then it's time for Stas to actually select the questions that he liked and give the present from Microsoft. And also I'm aware that Stas has some special presents from himself, right?
So I'm going to give the first question to the most commonly question I constantly get in how to debug it. So congratulations. And I have 2 copies